everyone. Today I am explaining you few reactions related with stereochemistry of electrocyclic reactions. You know that pericyclic reactions are very important for net and set, and generally questions related with stereochemistry and pericyclic reactions, and many reactions are given, and there you have to apply the stereochemistry concept, con-rotatory process, dis-rotatory process, thermal reaction or the photochemical reaction that you have to apply over there. And sometimes single reaction is given, sometimes many chain reactions are given where you have to apply this concept. So this is very important for net and set. Okay, so let's start with three examples I am discussing today, 1, 2 and 3, and they are 4-membered rings. Okay, generally reactions are given. So reactant is given, product is question mark, and this triangle sign is given. So you have to understand this triangle sign means thermal reaction is there, and if H nu is given, it is photochemical reaction, that you all know. Okay, up now it is thermal reaction. This ring opening of first example, cis 1,4-dimethyl cyclobutene, ring opening of this cyclobutene to butadiene. Okay, this is undergoing by thermal process. Okay, now second step is to understand whether this interconversion means the system is 4n pi electron system or 4n plus 2 pi electron system. If it is 4n pi electron system, as this interconversion, you see that this 1,4-dimethyl cyclobutene is converting into butadiene, or if reverse process you take ring closure of this product into this reactant. Okay, so both processes, they are involving 4n pi electron system, and you know that the process is thermal. So thermally 4n pi electron system undergoes by con-rotatory process, and photochemically, if photochemical process is there and this system is 4n pi electron system, then it is undergoing by dis-rotatory process. If 4n plus 2 pi electron system is there, then it is undergoing thermally by dis-rotatory process and photochemically by con-rotatory process, reverse of this 4n pi electron system. Okay, so let's understand this reaction, this interconversion of cyclobutene into butadiene. This is happening by con-rotatory process. What is con-rotatory process? For example, this single bond, you know that p orbitals are actually overlapping, then this sigma bond is forming. Okay, so if that orbitals which are here, for example, this way orbitals are there, both orbitals are there, okay, axially overlapping, then what is going on? Clockwise, okay, clockwise, okay, and these are also undergoing clockwise process. So both substituents, the sigma bond, 2 carbon atoms are involved in this sigma bond. So in both carbon atoms, this orbital is moving clockwise, this orbital is also moving clockwise. So the substituents present in these both carbon atoms are moving clockwise. Both carbon substituents are moving clockwise only, this way. This is this 2 arrows going to same side. Okay, so this product is formed clockwise, means this Me, this orbital will come here, and this Me will move outward, this H will move inward, and here Me will be moving inward and H is moving outward. Other possibility of con-rotatory process is also there. Okay, reverse of this means both are moving anti-clockwise. Both are moving anti-clockwise. Anti-clockwise, this way moving. Okay, so both carbon atoms substituents are moving anti-clockwise. Then this type of arrows are there. Okay, both are same side. These are also clockwise, both are same side. Anti-clockwise, both are same side. Okay, now if anti-clockwise, then this Me is moving inward, this H is moving outward, here this Me is moving outward, this H is moving inward. Okay, so you know that ZE configuration we are assigning to this, because this Me is cis to this double bond and this Me is trans to this double bond, so E. So ZE configuration is assigned to this isomer. Similarly, other way of conrotated process, so this Me is trans to this, so E, this Me is cis to this double bond, so Z. EZ configuration is assigned to this. In both examples, if you see that one Me is inward, one Me is outward. One Me is inward, one Me is outward. Now, in this video, actually I am explaining you, apart from only disrotatory and conrotatory process, some other factors are also responsible to predict the correct answer. Okay, and one of the very important factor is steric repulsion or steric hindrance. Okay, so we will see that if bulkier groups are coming closer, then that product will be less predominant. Okay, where less bulkier groups are coming in closer, that product will predominate. Okay, here in both products you see that one Me and one H is coming closer. Okay, so steric repulsion is same in both isomers. So by conrotatory process, steric repulsion or steric hindrance has no role. It is not playing any role in this conrotatory process. When we discuss the rotatory process by photochemical process, you know that 4 and pi electron system. Now this ring opening is happening by photochemical process. So photochemically it will be a disrotatory process. Disrotatory process is what? If one orbital is moving anti-clockwise, other is moving clockwise. Okay, other is moving clockwise, that way. Okay, when this on this carbon atom, this orbital is moving clockwise, this Me will move outward, this H will come inward. Similarly here anti-clockwise, so Me will move outward and H will come inside. Okay, so this way the mechanism, both mechanism I have explained it to you, conrotatory and disrotatory process. But here also, if we are saying that if one carbon substituents are moving clockwise, other is moving anti-clockwise, reverse can also happen. Okay, if this is moving clockwise, this is moving anti-clockwise, then this product will be formed. This product will be formed. Okay, this is moving clockwise. Anti-clockwise. This is moving anti-clockwise. So Me will come. Me will move inward, and this H will move outward. Okay, here anti-clockwise, so Me will move inward and H will move outward. So this product will be formed. Here you can see that both Me compared to HH, Me are closer and they are bulkier group. So steric repulsion plays an important role. Okay, and so because of this steric repulsion, this product is never formed. Okay, this is not forming. So only through single disrotatory motion in which Me moves outward, as inward movement of Me incurs excessive steric repulsion. Okay, so this way we will predict the possibility of the product. Okay, so steric repulsion also we have to consider. Here it doesn't play any role, but here only single disrotatory process is there. Okay, because of this steric repulsion. Come to second example. Second example, here also this is trans 1,4-dimethyl cyclobutene ring opening we are seeing by thermal process only. Here we are actually I am explaining you the steric repulsion factor, how it plays an important role. So by thermal process will take place by conrotated process, and by conrotated process two possibilities of conrotated process is there. One is this and one is this. Okay, so by conrotated process what happens? Conrotated process, if anti-clockwise we are seeing anti-clockwise. Okay, so anti-clockwise this anti-clockwise. Okay, and this is also going anti-clockwise. So H will move inward, ME is moving outward. Here ME is moving outward, okay, this side, and H is moving inward. Okay, so EE configuration is there, right? If the second possibility of conrotated process we see, then by thermal process, right? So both here both are moving anti-clockwise. Now both will move clockwise. So clockwise, both will move clockwise. So what will happen? H will be moving outward, ME is moving inward. Here also ME is moving inward and H is moving outward. So here you see that steric repulsion is playing important role. Okay, so this product will never be forming. Understood? So this is not forming, this is only forming. Only one way of conrotated process is there. Right? So only EE configuration isomer will be formed, ZZ will not be forming. Okay. Now apart from steric hindrance, generally in net set exam, if we see that steric repulsion is there, we eliminate that answer. Okay, but this is not the always happens. Okay, in this case, if you see that apart from steric repulsion or steric factor, one more factor is playing an important role, and that is electronegativity. Consider third example. This is fluorinated cyclobutene, and here Fe is having high electronegativity. Okay, and the rule is that the substituent which is having higher electronegativity will be moving outward. Okay, so here if you see that clockwise is there, this is moving clockwise. This is moving anti-clockwise. Here is anti-clockwise. Both are moving anti-clockwise. Thermal process is there, and the system is 4n pi electron system. So thermal process is conrotated process. Both are moving anti-clockwise. So here though there is no difference because both substituents are same. Here anti-clockwise. CF3 is moving inward and fluorine is moving outward. Here in this process, if we see the other possibility of conrotated process, okay, so clockwise, both are moving clockwise, then what will happen? CF3 is moving outward, F is moving inward. Here F is here both are F only, so there is no difference in the here, both are F only. Here only this product, when CF3 is falling inside and fluorine is moving outward, this will predominate. Okay, so when thermal process 2 possibility of conrotated process is there, then instead of 5, 4 will predominate. Okay, only this product will be formed, this is not forming. So this process will not happen where the substituents are moving, both substituents are moving clockwise by conrotatory process. Okay, so always one factor is not there. Whenever you are solving the questions related with pericyclic reactions, electrocyclic reactions, many more factors are there which also you have to keep in mind. Okay, hope you have understood. Thank you so much.